Hey everyone, and welcome. Today, we're going to pull back the curtain on something that runs our entire digital world, but most of us never see compliance. We're going to explore how these hidden rule books don't just guide how apps are built, they are literally the blueprints. So let's jump in. All right, let's kick things off with a bit of a riddle. What could a massive steel and glass skyscraper possibly have in common with the app you just used on your phone? I mean, on the surface, they seem like total opposites, but they are both built on the exact same, absolutely non-negotiable idea. And there you have it. You see, a skyscraper has to follow incredibly strict building codes for things like wiring, plumbing, structural strength, all to make sure the people inside are safe. Well, it's the exact same story for a cloud application. If it's handling your sensitive data, it has to follow its own set of digital building codes, and we call those compliance frameworks. Now, it makes sense, right? You wouldn't use the same building code for a single-family home as you would for a giant hospital. And in the same way, the digital world has all these specialized rule books for different kinds of data. Let's take a quick look at some of the heavy hitters. First up, PCI DSS. This is a big one. If any app or system wants to process, store, or even just pass along your credit card info, it has to follow these rules. No exceptions. This is the framework that keeps your card details safe every time you buy something online. Then you've got HIPAA. This is the rule book for everything in the healthcare world. It lays out the law for how to secure personal health information, everything from your test results to your insurance records. It's incredibly important. And rounding out our list is SOC 2. Now, this one's a bit broader. Think of it as a stamp of approval that proves a company can be trusted to manage its customers' data securely. It's all built around core ideas like security, privacy, and confidentiality. Okay, so here's the really crucial point to get from all of this. These frameworks, they aren't just boring checklists for auditors. For the engineers and the architects actually building cloud systems, these rules are the blueprints. They fundamentally shape how an application is designed and built, right from the very beginning. And this slide right here shows you exactly what I mean. On the left, you've got your basic, simple app design, a web server, an app server, a database. Pretty standard stuff. But now look at the right. To make that same app compliant with PCI rules, the architecture has to change dramatically. The rules force you to add things like segregated networks to wall off sensitive data, constant file monitoring, way stronger encryption, and super strict controls on who can access what. The rules literally add new rooms and security systems to the blueprint. To really bring this home, let's quickly walk through a case study. We'll stick with our payments example, PCI, and look at the key design choices an engineer is forced to make because of those rules. Okay, so if you're building for PCI, you have to follow these core architectural steps. 1, you isolate the environment. You create this protected digital bubble. It's often called a cardholder data environment, where only payment data can live, totally walled off from everything else. 2, you encrypt data everywhere, not just when it's sitting on a hard drive, but also while it's flying across the network. 3, you use what's known as least privilege access. This just means people and systems can only touch the absolute bare minimum they need to do their jobs and nothing more. And 4, you are constantly, and I mean constantly, watching the logs and testing your security to prove that everything is locked down. Now, all that sounds pretty manageable when you're building in one place, right? But here's the catch. Today's world is multi-cloud. So what happens when your one perfectly designed skyscraper suddenly has to be built across 2 different cities, and each city has its own set of building codes, its own tools, its own construction crews? This is the dream scenario. In a single cloud, you can build a beautiful, consistent, compliant system. Everything's in one place, you're using one set of tools, you're following one clear rulebook. It's clean, it's simple, it's manageable. But this is the reality for so many companies today. The same application gets ripped in two, with parts running in AWS and other parts running in Google Cloud. And you can see the problem immediately. You still have to follow the same set of compliance rules across the whole thing, but the security tools, the way data is logged, the systems for managing who gets access, they're all totally different in each city. That split creates so much confusion and complexity for the people who have to build and secure. So what does that mess actually mean in practice? Well, you're trying to use security tools that weren't designed to talk to each other. You have different data controls in each cloud, which makes it hard to enforce one policy. Trying to create a single audit trail to track a transaction that crossed both clouds, that's a nightmare. Even something as basic as logging becomes a huge headache because each cloud formats its logs in its own unique way. You're basically creating friction and risk at every single connection point. And that really brings us to the single most important takeaway here.
For anyone building things in the cloud today, compliance cannot be an afterthought. It's not just some checkbox you tick off at the very end of a project. It has to be a fundamental design discipline. It has to be woven into the architecture from the very first decision you make. It's all about building it right and building it securely from the start. So I'll leave you with this final thought. As our digital world becomes more and more spread out, just scattered across this borderless, multi-cloud landscape, does it really make sense to keep trying to patch together different rule books for different places? Or is the next great frontier, the next big challenge, to create a truly universal building code for our data? One set of rules to keep it safe, no matter where in the world it happens to live.